Hello, thank you for watching this video, and please remember to subscribe to our channel so you will get notifications about new videos. I want to make another video about vectors. In this case, we're going to see this exercise where they give us two vectors, a vector A with a magnitude of 5 meters and is 40 degrees above the negative x-axis, and we have a vector B, right, with a magnitude of 4 meters and is 20 degrees above the positive x-axis. They say then, that given those vectors A and B, and given that vector C is vector A plus vector B, they want us, they want that we find the vector C, and we must write the answer in components using unit vectors. So the first we're going to do in this case would be to find the components of the vector A and the vector B. So I know the vector A would be a sub x I plus a sub y j. Now, what is a sub x? Of course, a sub x would be in this case a cosine of the angle, so it would be 5.0. I will enclose this in parentheses. 5.0 cosine of 40 degree I, with a negative sign, because we know that this component, the x component of the vector A, will be negative, plus 5.0 sine of 40 degree j, and this is in meters. So if I now calculate A, I will get that A is going to be in this case negative 3.83 I plus 3.21 J. Now we're going to do exactly the same, for vector B. So we know that vector B is b sub x I plus b sub y j. So it would be, in this case, 4.0 cosine of 20 degree I. Remember that the x component is adjacent to the angle, so that's why we use the cosine function, plus 4.0 sine of 20 degree j. All this is in meters. I forgot to say here, that these are just meters, so is a unit of length. So now when I calculate the the components of the vector B, I will get that 4.0 cosine of 20 would be 3.76 I plus 1.37 j. All these in meters, of course, right? So now we're ready to find the vector C. There is vector A plus vector B. So we're going to be adding the I component, that means the x component, so the components containing the unit vector I. So it will be negative 3.83 plus 3.76 I, of course, plus then now we have 3.21 plus 1.73 j. So we're gonna get, of course, that this vector C is equal to negative 0.07 I plus 4.6 j, and of course the unit here is meters. So in this exercise we found the magnitude, I mean, the components of the vector c that was equal to vector a plus vector b, and we express those components using the unit vectors. Our next exercise here is an exercise where we're going to use some tools of calculus, right? They say that the position of a particle as a function of time is given by vector position r equals 5.0 plus 4.08 t squared in meters, of course, because it's position. So where t is in seconds. So they ask you what is the particle distance from the origin at t equals 0, t equals 2, and t equals 5 seconds. Then they say find an expression for the particle's velocity v as a function of time. And then they say what is the particle's speed at t equals 0, t equals 2, and t equals 5 seconds. So the first here is to find, what is the position when the particle is at 0 second. So basically, we're going to find out of 0, and out of 0 would be in this case 0. So in this case, the distance of the particle from the origin is 0 meters. So the particle is basically on the origin. In the second case, they want to, that we find the position of the particle when t is equal to 2 seconds. So we must find out of 2 seconds, right? What is going to be, if we use the equation we have over here, it will be 5.0, and I will use the symbol of vector here, 5.0 I plus 4.0 j times t squared, so it will be 2 seconds square, and of course the unit here is in meters. So I will get out of 2 seconds, would be we're gonna get here 5.0 I plus 4.0 j, and this is now 4 seconds square, right? Or we can say just 4, right? Because the units inside here, right, must be so that we can just cancel out the seconds square to get meters. So let's say that I will multiply this just by 4, because 2 squared is going to be 4. So out of 2 seconds, would be 4.0 times 5.0 times 4 would be 20 times 20.0 I plus 4 times 4 would be 16.0 j, and this is in meters. Now if I want to find the magnitude of r, this would be the square root of 20 square plus 16 square. If you calculate that, you're gonna get that this is approximately 25.6 meters, so it's basically 26 meters. So now we know that 2 seconds after the start of the motion of the particle, the particle will be 26 meters from its origin. For 5 seconds would be exactly the same thing, so I am not going to be just spending more time than doing that for time equal 5 seconds. So you can do it by yourself. You can evaluate r at 5 seconds. In the second part, they say find the expression for the particle's velocity v as a function of time. So what we know in this case, we know that v is the first derivative of the position respect the time. So we know that v is dr dt. So if we have, you know, that r is the function 5.0 I plus 4.0 j t squared, and we are going to derivate this, you know, respect to time. So we have dt, right? We're gonna get here what? Of course, this the derivative of t squared dt, it would be in this case just 2t. So we're gonna get this is 2t times, right, 5.0 I plus 4.0 j, right? I would then multiply by 2, so we get that my velocity, and I will just rearrange my factors. My velocity would be 5.0 times 2, so it's going to be 10.0, right? So let me fix this here. It will be 10.0 I plus 8.0 j t, right? So this will be now my equation, and this will be in meters per second. Okay, because of course you multiply the scalar 2 times, you know, both components, of course, right? So now this is your equation for velocity, 10.0 I plus 8.0 t in meters per second. So in part C, they ask you to find the velocity at time equal 0 second, and when t is equal to 0 seconds, b of 0 seconds, right, it will be 0, of course, because we're going to replace this t over here by 0, and you multiply by 0 the vector you have here, so you will get 0. In the second case, they ask you to evaluate when t is equal to seconds, so you're going to say that b at 2 seconds is 10.0 I plus 8.0 j, right, times 2 seconds, right? And then now we're going to get that b of 2 seconds is 10 times 2 would be 20.0 I plus this would be 16.0 j in meters per second. If now I want to find, you know, the magnitude of the velocity, that magnitude would be the square root of 20 square plus 16 square. So I know that the velocity in this case would be approximately, you know, 26 meters per second. You know, 26 meters per second. This would be the velocity after 2 seconds. So here you have one example, you know, where we are using some tools of calculus, right, to work with the vectors. So I hope, you know, these exercise was or these two exercises were interesting for you. If you found this interesting, just subscribe to my channel so you get notifications of new videos. And thank you so much, you know, for your attention.